Today we're talking about the math properties, the operation properties. It's called the operation properties because they're properties that we can do on the different math operations. Addition, subtraction, multiplication, and division. Things that we're allowed to do with the properties. Again, in math, there are things we are allowed to do and there's things that we're not allowed to do. The properties describe the things we are allowed to do. We'll start with the first property, which is the commutative property. There are two commutative properties. There's a commutative property of addition, and there's a commutative property of multiplication. There's two different versions of the commutative properties. Oftentimes when we hear the commutative property, the word you should be thinking of that builds in there is the word commute. To commute means to go from one place to another place. When you hear about your parents, they might in the morning complain about the traffic commute. Man, the morning commute today was so bad. I had so much traffic. The commute is when you go from one spot to another spot. I commute to work every day. You commute to school every day. You go back and forth between two different spots. Does anybody in here have a parent who commutes to DC? So a long commute for you guys. Anyone have a parent who has a short commute? Short commute for you guys. In either event, you're moving to a new spot. And that's what the commutative property says. Just like people drive from home to work and back and forth, the commutative property does the same thing. You switch the order in which you were. It was here, and now it's here. You're changing to where you were. A was left and B was right, and now we flip-flop. They change to a new spot. You can also look at the C and the O in commutative property. The C stands for change, and the O stands for order. You're going to change the order in which you see the numbers. The thing about all these properties, again, is they need to be true. Here's an example. 4 times 5 equals 5. Sorry, 4 plus 5 equals 5 plus 4. They're the same thing. Here's what I mean. What's 4 plus 5? 9. What's 5 plus 4?
9.
Also 9. It has to be true. If it's not true, it's not one of the properties. All of the properties are true. So 4 plus 5 equals 5 plus 4. We can do it with 3. You can contain a variable. You're just changing the order. Similarly, the commutative property of multiplication is pretty much the same thing, except with multiplication. A times B is the same as B times A. The multiplicative commutative property with an example, 10 times 3 is the same as 3 times 10. Yeah, well, what's 10 times 3? 30. What's 3 times 10?
30.
Also 30. They have to be true in order for it to be a property. Here's one with variables and 3 of them. This is not an x for multiplication. Stop using x for multiplication. This is 7 times the variable x times 4 equals 7 times 4 times x. We're just changing the order. The next property I'm going to talk about is the associative property. The associative property also has two versions. There's the associative property of addition, and there's the associative property of multiplication. Backtracking slightly, since there's a commutative property of addition and a commutative property of multiplication, an associative property of addition and an associative property of multiplication, I do want to mention that there is not a commutative property of subtraction, and there's not a commutative property of division. Those do not exist. Likewise, the associative property, there is not an associative property for subtraction and not an associative property for division. So those properties don't exist. It's just for addition and multiplication. The associative property, to associate means to hang out. You guys hang out with your friends, you guys hang out with your family. Numbers hang out with other numbers. But more importantly, the associative property is a bullying property. The associative property is a property of exclusion. It's a property of bullying. So this property is a bullying property. It's a property of exclusion. There's a teacher that I taught with at Eagle Ridge. She called the associative property, so I'm not going to take credit for it. It's called the 8th grade girl property.
That sounds about right. That sounds very...
And so here's why it's called the 8th grade girl property. Those that know any 8th grade girls may understand it. So here's the associative property. B is like, oh my God, A, we're BFFs and we're friends forever, and we're never gonna not be friends. Oh wait, you talked to that boy? You are out. And you cannot sit at this table anymore. I'm just talking with C, and A, you can find some new group of friends because you are out of the club.
Yep, that's how we call it.
That is the associative property, also known as the 8th grade girl property. It is a property of bullying. It is a property of exclusion. If we look at an example with numbers, I want to remind you that it has to be true. And here's what I'm saying. These parentheses dictate the order of operations. So first I do 9 plus 7, which is 16, plus 3, which is 19. On the right-hand side, 7 plus 3 comes first, which is 10, and 9 plus 10 is also 19. They have to be true. If it was not true, it would not be one of the properties. So of course we could do it with a bunch of numbers, and we could certainly do it with 3 numbers, and we could definitely do it with variables. In this case, 8, 4, and pi are the same. Now 8, 4, and pi is out, but they would F. Note that the order does not change. 9, 7, 3, 9, 7, 3. If the order changed, it would be the commutative property. There is also an associative property of multiplication. And that is pretty much the exact same thing, except with multiplication. A times B times C equals A times B times C. The order stays the same, just who's associated changes. Can use variables. Down here, an associate, which is a noun, associate, is a companion or a comrade, an accomplice, or an ally. So the associate is someone that you're friends with. 5 and 10 are associates. Now 5 is with the other 5. The third property we're going to talk about today is the distributive property. The distributive property is also known as the whoosh property. Distributive property, also known as the whoosh property. Technically, the distributive property is called the distributive property of multiplication over addition. You do not need to know that. There's not a distributive property of addition and a distributive property of multiplication. There's not 2 different distributive properties. There's one distributive property. It's called the distributive property. If you want the long name, it's distributive property of multiplication over addition, which is why the whoosh comes into play. The whoosh. Why is it called the whoosh property? Here's what the distributive property looks like. What it says is, instead of A times the entire quantity B plus C, I could just multiply A times B, and then add that to A times C. So instead of doing A times the entire middle part, I can distribute the A, give out the A, so B, you get an A, and C, you get an A. So I whoosh and I whoosh when I distribute. Here's another example with some numbers of the distributive property. I could do 3 times 4 plus 5, or I can do 3 times 4, whoosh, and 3 times 5, whoosh. Now it's true, and I'll show you that it's true, because let's do it. What is 4 plus 5?
9.
And what is 3 times 9?
27.
Let's do this side. 3 times 4? 12. 3 times 5?
15.
And of course 12 plus 15 is
27.
27. You guys use the distributive property quite a bit when you do long multiplication problems. It also works with variables. Whoosh, 10 times x is 10x, minus sign, 10 times 7, we'll write this as a 70. And it also could be a whoosh, whoosh, whoosh. Whoosh, whoosh, whoosh. We're just going to whoosh and distribute them all out. This is called the distributive property. Again, it's called the distributive property of multiplication over addition because when you do this, you distribute multiplication over addition. This is where students sometimes start to get confused. The next 2 properties. The identities. Your identity is who you are. Who you are does not change. There is an additive identity and there's a multiplicative identity. The identities. I like to call the identities, when I reference these identities, I like to call them the waste of Those properties are a waste of time. Those properties, you do them and you go, oh, well, thanks for wasting my time. There was no point for that. Didn't really do anything. And that's what the identities are. Again, your identity is who you are. Who you are does not change. So here's what the identities say. There's a number that I can add where you will stay the same and you will keep your identity. And that number is 0. Any number plus 0, oh, it was just A. Well, that was a waste of my time. I added 0. I should have just done nothing because I would have ended up with the same letter A. 0 plus 65 is still 65. Well, again, that's a waste of my time. Add 0, it was the same thing. That was, again, a waste of my time. 3,778,440 plus 0 is the same thing. It was a waste of my time to do that. There is also a multiplicative identity. A number that I could multiply by, that would be a waste of my time. Does anyone know the multiplicative identity, the number that I could multiply by, where I would keep my identity, and you say, well, that was a waste of my time? 1. So A times 1 is just A. Multiply any number by 1, 18 equals 18 times 1, and 1 times apple is apple.
It's true, it's not fake.
It's true. You multiply by 1, stay the same. That is the multiplicative and additive, and then again, it's kind of a waste of my time. Thanks for wasting my time. While I have you guys in this spot, we're in a good spot, let me give you a couple examples, see if I can show you some tricks that they ask on quizzes, tests, and a lot of times on SOLs, and see if we can figure out what the correct answer is and what they would try to trick you with. What math property are they trying to demonstrate in this example? What math property are they trying to demonstrate in this example? The two guesses I wanted to hear, we just heard them in class, was the commutative property of addition and the additive identity. I wanted you to think it was the additive identity because you think, oh, plus 0. That's the additive identity. But this is an example of the commutative property of addition because I'm switching the order. In order for it to be the additive identity, it would have been 8 plus 0 equals
8.
Just 8. That's the additive identity, where you stay the same. Let's do another example. What property are they trying to demonstrate with this example? Once again, for this one, I asked students, and the two guesses that I heard were the two that I wanted and expected to hear: associative property of addition and commutative property of addition. And this is an example of the commutative property of addition. You'd think it was the associative property because the parentheses moved, but you got to be careful. Who's associating didn't change. 3 is with 6 and 3 is still with 6. What did happen was this set of parentheses was on the right-hand side, now it's on the left-hand side, and 5 moved and they flip-flop. That's the commutative property of addition. So have to be careful. Those are types of tricky questions they like to ask. All right, the next ones are the inverses, and again, there are two inverses. Inverse sounds like reverse. So you should be thinking inverse, reverse, inverse, reverse. Some students get these confused because inverse and identity both start with I, but they could not be further from each other. They're total opposites. Inverse and identities are opposite. There's the additive inverse and the multiplicative inverse. Additive inverse and the multiplicative inverse. If inverse is the reverse, what is the reverse with adding? Well, in order to get to the reverse, you take whatever number you have, add the exact opposite. So if I had A, I would add negative A, and that would get me back to 0, the exact opposite. Maybe it helps with numbers. 4 plus a negative 4 is 0. It's almost like a 0 pair, which 4 positives and 4 negatives is nothing. It's almost like a 0 pair, where it turns to 0. Here's another example. 0 plus a quarter. Sorry, 0 equals a quarter plus a negative quarter. They cancel each other out. They're reverses. They're additive reverses. They cancel each other out. The multiplicative inverse, on the other hand, is a little bit more complicated. Because I will not just be multiplying the opposite. You will not see A times a negative A. Because A times negative A is just negative A squared. And that's not inversing anything. In order to inverse A, what I have to do is I have to multiply by 1 over A. Now that may seem confusing, so don't copy anything down just yet. We'll talk a little bit more about it. These are actually called reciprocals. So these two numbers are called reciprocals. And what reciprocals are is when you take a fraction, let's say 2/3, and you flip it upside down, 3 over 2. Those are reciprocals of each other, and they're inverses, because here's what happens. What's 2 times 3? 6. What's 3 times 2? 6. So of course 6 over 6 is 1. And when it turns into 1, these are called inverses of each other. Here's another example. 3/4 times 4/3. These are reciprocals where you flip them upside down. Here's another one with the number 10. You might be saying, well, how is 10 and 1/10 flipped upside down? 10 is not a fraction. Well, yeah, it is. It's 10 over 1. Any whole number is 10 over 1. They flip it upside down 1/10. And those are reciprocals of each other. So multiplicative inverses are a little bit trickier. It's not just a positive and a negative like it is for additive inverses. With multiplicative inverse, you got to flip them upside down and get what's called the reciprocal. 2/3 and 3/2, 3/4 and 4/3, 10 and 1/10. And then they will cancel each other out and turn into 1 for the inverse sake and turn to 0 for the additive inverse sake. And the last property is the easiest property of all. It's the multiplicative property of 0. It says if you multiply by 0, you get 0. That's a multiplicative property of 0. It says if you multiply by 0, you get 0. In other words, 194,631,223 times 0.1 times 0 is just 0. Just blows it up, multiplicative property of 0, turns everything to 0.